This lesson, let's learn addition and subtraction with logarithms. And before we get into the rules, let's just review what we have learned before. So what is the value of log 2 8? So this is basically asking you to what power of 2 is 8? So 2 cubed is 8 and it's 3. So what is the value of log 3 27? Still, 3 cubed is 27, so the answer is 3. And it must be very clear and familiar with counting logarithms. And let's do the next one. So what is the value of log 2 32? You can count on how many times you have doubled. So 2, 2, 1, 2, 3, 4, 5. So 5 twos is exactly 32. So the answer is 5. Since 2 to the power of 5 is 32, and the answer is 5. And log 2 4 and log 2 8, count them. The first one is 2, because 2 squared is 4. And third one is 3. 2 cubed is 3. And now, let's consider a simple addition. So log 2 4 plus log 2 8 is, what is the value? So it's independently 2 plus 3. So it will be 5. And as we have calculated, 5 is also log 2 32. So what kind of conclusions can you get from the equation? So see, 4 times 8 is 32, right? So that is the rule of addition. Outside is addition, but inside you just need to do the multiplication. And that's how you count logarithms. I'm just using an intuitive way to show it. I'm not proving it. In order to prove it, you have to use some variables to do that. But I think this is a primary course, so we don't have to focus on induction. And for log 2 32 minus log 2 8, it would be 5 minus 3, which is 2. And the value of 2 is log 2 4. So you can observe the rules here. What is the rule of subtraction? You see, outside it's subtraction, but inside is division. So from these two equations, we can roughly get two rules, and then we could prove it. The first is log AB plus log AC. Outside it's addition, but inside it would be multiplication. Still, log AB minus log AC. Outside it's subtraction, and inside it should be division. And these two rules are 100% correct. I'm just using a very intuitive way to show you how to use it. So let's just try to use the first one. Log 3 100 over 3 plus log 3 6 over 50. So how to count this addition? Well, let's just use the rules. Outside is addition, so let's combine them together. It will be multiplication. So it's log 3 100 over 3 times 6 over 50. And let's simplify them. So it would be log 3 4. It's very easy for you to use the addition rule. And you must get familiarized with this. So you see log 2x plus log 2x plus 1 inside the bracket. So in order to simplify them, we can combine them by using the addition rule. So inside it will be multiplication, which is x times x plus 1. It's a very common rule to combine them together. You will see how they are used later. And then let's use the subtraction rule. So for subtraction, log 2 100 minus log R 50 250. So outside it's subtraction, so inside it will be division. So log 2 100 over 50, which is log 2, which is 1. And then you have calculated out. Let's do a bit of deduction to get the third rule. So you see 2 times AB. That means you have exactly the same things added together. And for the addition, inside it will be multiplication, b squared. And the same rule can be applied if we have 3 of them. So it means we need to add 3 of them together. So we need to time it for 3 times, so b to the power of 3. And it could also be applied as when we change it to 4, we have 4 log AB. So if we want to add them together, we need to time b to the power of 4. Because the 2 combined, which will be b to the power of 2, and the second combined with the third, that will be to the power of 3, and combined with the last one, it will be b to the power of 4. So concluded from this, we can get the third rule, which is very commonly used and very important. So log AB, and here n times it will be AB to the power of n. You can remove n outside into the power of b. So you can see here, 2 times log 3x can be simplified as 3x to the power 2, or 5 times 4x could be simplified as 4x to the power of 5. It will be very useful for the later when we are solving logarithm equations. Let's try a simple example. Log 3, 2 times it, plus log 5 plus 3 log 2 equal log 2x. So how to get the value of x? We have to combine those values on the left side together. And using the logarithms rules, we can remove 2 inside it to the power of 3. So it would be log 2 9 plus log 2 5, and for the 3 we could also remove it to the power of 2 plus log 2 8 equals log 2x. And outside it's addition, inside it should be multiplication, so it's log 9 times 5 times 8 equals log 2x. So they're wearing the same clothes, they all have logs. So we can just focus on the inside. So x equals 9 times 5 times 8, which is 360. So it's very common for this kind of equation. So let's see this. Log 2x squared plus 2x equals log 2 3. Because they're wearing the same clothes, so inside it, x squared plus 2x equals 3. It's the same when we are using exponents. 2 to the power of x squared plus 2x equals 2 to the power of 3. Because they are wearing the same clothes, so x squared plus 2x equals 3. And even though we haven't learned trigonometric functions, but I can show here in advance, sine x squared plus 2x equals sine 3. So they have the same clothes inside it, x squared plus 2x equals 3. It's a very common way for solving this kind of equation. So next time when you have no idea, you can just try to make them look the same, look similar, and then to find the pattern behind it. Well, as for deduction, I might show it just a little bit. It's not a big deal. You can just well, if you are not good at math, you could also ignore it, skip it. So a to the power of n times a to the power of n is a to the power of m plus m. So let's a to the power of m equal x, and a to the power of n equals y. And then we could see xy equals a to the power of m plus n. Right, in the logarithm form, we could get m equals a log from the m equals log ax and n equals log ay. So let's try to find the roots here. And from this, we could get m plus n is log axy. So we see m plus n is log ax plus log ay, which is log axy, and that's how we prove it. It's just a simple picture. If you have no idea how to deduct it, it's totally fine because it's not tested in the exams. It's just for logic, for being serious. And it can also be proved for the second rule of subtraction, but I don't think that's necessary. You can just still use the same way. Set it as m, set it as n. So here you can use the exponents to express it and then prove the second rule. You can try it. I will not show. But just one more reminder. Y equals ln x means log ex, and you should know the base e here. E is a natural base. So ln e equals 1, because e to the power of 1 is e, and ln e squared is 2. You must get very used to this new expression. Practice those rules well. They are very essential for solving more complex logarithm equations later, and they are very important in calculus as well. So that's it for the lesson, and thanks for watching.